Hello. In this video, we're going to learn about Rule 5, the exponential derivative. So our question is going to be to investigate the derivative of e to the x. Now, the way we're going to approach this is we're going to start with the definition of the derivative. So the derivative of e to the x will simply be the limit as h approaches 0 of e to the x plus h, because it's f of x plus h and our function is e to the x, minus e to the x all over h. Now, if we plug in h equals 0, we'll have e to the x minus e to the x, so we'll have 0 over 0. We'll need to do some more work. And so, to work on that, what we're going to do is take the e to the x plus h and do a little exponent rule. So we will rewrite this as the limit as h approaches 0 of e to the x, e to the h, minus e to the x all over h. Now, what we've done is, again, said, normally if you have the same base, you add the exponents. And so what we've just done is taken two exponents that are added together and split them up into two separate bases. Why might we do something like that? Well, if you see here, we have an e to the x, we have an e to the x. So we have an e to the x in common, and we can take that out. So we have the limit, as h approaches 0, of e to the x, and then we'll have e to the h minus 1 over h. Now, again, if you were to plug in h equals 0 to this expression here, you'd have e to the 0, which is of course 1. Anything to the power of 0 is 1. So you'd have 1 minus 1 over 0, which is still, unfortunately, 0 over 0. But what we're going to do is a little bit of numerical investigation. So if we see here, we have the h, and we have e to the h minus 1 over h, the expression we're going to investigate. And so if you take h equals to 0.1 and you plug it in on your calculator, you should get the value 1.052, rounding off to 3 decimal places. Now if you plug in h equals 0.01, you should get 1.005. And if you plug in 1.001, and I encourage you to do this, you should get 1.0005. So what does it look like e to the h minus 1 over h is approaching as h approaches 0? Well, I think the answer is obvious. It looks like it's approaching the number 1. And so if we actually take a look at a graph here, this graph is generated just by typing in e to the h minus 1 over h on Desmos. We can see that there's a hole here. We clearly can't evaluate the expression at h equals 0. But as we approach 0, the y values clearly appear to be approaching the value 1. And so what we can do then is go back to our limit, and we'll get the limit as h approaches 0. Well, e to the x is just a constant with respect to h, so we'll just have e to the x. And here we'll have 1. So we'll simply have e to the x. Well, let's write that down then a little more formally here. Remark, the derivative of e to the x is itself. d dx of e to the x is simply e to the x. Now, I think this is a very interesting result. When we worked with other derivatives, for example, the derivative of maybe x to the 3 was 3x squared. The derivative changed the function from x to the 3, and its derivative was 3x squared. But when you take the derivative of e to the x, you simply get e to the x back. The analogy I like to use is the derivative here is sort of like a Pokeball. And e to the x, it's a legendary Pokemon. Maybe something like Zapdos. And so when you use a Pokeball on that Pokemon, it just pops right back out. It doesn't matter how many times you put that Pokeball on the Pokemon, it's going to escape every time, and you're just going to be left with the original function you started with. Now let's do a couple examples, and I encourage you to try each one here. Pause the video, try the example before I do it. But let's do the first one, the derivative of 7e to the x. Well, again, the constant will factor out of the derivative, so we're just looking at really 7 times the derivative of e to the x. And of course, the derivative of e to the x is simply e to the x. So it's 7 e to the x. And you can just write that directly. Now how about the derivative of x to the 5 plus e to the x? Well, again, the derivative of a sum is the sum of the derivatives. So it'll be 5x to the power 4 plus derivative of e to the x, e to the x. And how about this last one here? 3 square root x to the 3 plus 11 e to the x. The first step would be to rewrite the hidden exponents. So this is a 3 x to the 3 over 2 plus 11 e to the x. And then we go ahead and do the derivative. So we get 3 times 3 over 2 x to the 1/2 plus 11 e to the x. Now if you want to be fancy, you can multiply those 3's and get 9 over 2, but you're more than welcome to just leave your answer like that. Now to practice what we've been working on here, I would like you to try the following homework problems. On page 180, work on questions 3 through 39. Thanks for watching.